This video is going to cover the 7-6 warm-up and then the notes for 7-7. So if you haven't already given everybody about 5 minutes to work on the 7-7 warm-up, or 7-6 warm-up, sorry, go ahead and pause the video and then replay it when you're ready for the answers. Okay, so the directions say to use the diagram for exercises 1 through 3. So we're going to use this triangle at the right here to answer these questions. Number 1 says if x is 4 root 5, so if I rewrite 4 root 5 on the x, and y is 4 and z is 4 root 6, find the sine of x, the cosine of x, and the cosine of y. So I'm going to start with the sine of x. Sine of x. Remember our acronym SOHCAHTOA, S-O-H, C-A-H-T-O-A. Sine is the first 3, so sine is going to be opposite over hypotenuse. In this triangle, the sine of x would be opposite x, and this is the angle x, so opposite x, which is 4 root 5, over the hypotenuse of this triangle, which is 4 root 6. Now the 4's are going to cancel out, and I get root 5 over root 6, but you can't leave that square root in the denominator, so I'm going to multiply both the numerator and the denominator by root 6, and then square root 5 and square root 6 is square root 30, over square root 6 times square root 6, which is just 6. You want to double check that you can't break 30 down, which 5 and 6 would be 5 and 2 and 3. Nothing's going to repeat. So that's going to stay as the most simplified form of the sine of x. Then the next one said find cosine of x. Cosine of x. Now cosine's the middle, CAH, which is adjacent over hypotenuse. Adjacent to angle x is both the hypotenuse and the y, but remember we use z as the hypotenuse only, which means adjacent is going to be 4. Hypotenuse is again 4 root 6. The 4's will cancel, and this is 1 over root 6. And then we rationalize by multiplying both the top and the bottom by root 6. And I get square root 6 over 6, which is as simplified as it can get. So that's the cosine of angle x. And the last one says to find the cosine of y. And again, those are angles. So the cosine of y is again adjacent, which this time is 4 root 5, over the hypotenuse, which is 4 root 6. And that's the same thing as up here. This reduced to root 5 over root 6, which rationalized to root 30 over 6. And it should make sense that the cosine of one of the angles, one of the acute angles in a right triangle, would be the same as the sine of the other acute angle, because opposite becomes adjacent and adjacent becomes opposite when we switch angles. Okay, number 2 says if y is 10, the measure of angle y is 15, find z to the nearest tenth. So z in respect to that, well, z for the whole triangle is my hypotenuse, and then the 10 in respect to the 15 is opposite. So when I look at, again, SOHCAHTOA, we want to find the one that has the hypotenuse and the opposite side. Opposite and hypotenuse is sine. So we're going to say the sine of 15 equals opposite, which is 10, over hypotenuse, which is z. The number's in the numerator, so we're going to take that number and divide it by the opposite side. And z equals 10 over the sine of 15. We're going to grab the calculators, and we're going to do 10 divided by the sine of 15. If your calculator stores the word sine. If it doesn't, then you're going to do 10 divided by 15, then you're going to hit the sine button, and then you're going to hit the equal button. So this is if it doesn't store sine, or sine doesn't appear when you hit the button sign. This is if it does, 10 divided by sine of 15, and I get that z equals 38.63. It says to round to the nearest tenth, so because that's 3, that's going to drop off and leave me with just 38.6. Number 3 says if z is 12 and the measure of angle X is 84. Find Y to the nearest tenth. So in respect to 84, I've got the hypotenuse and I've got the adjacent side. Again, SOHCAHTOA. Adjacent and hypotenuse is cosine. So I'm going to say the cosine of angle 84 equals the adjacent side, which is Y, over the hypotenuse, which is 12. Now the number's in the bottom, so I just multiply by that on both sides. 12 times the cosine of 84 equals Y. 12 cosine 84 gives me Y is 1.25, which is going to round to 1.3. If your calculator does not store the word cosine or show the word cosine when you hit it, then you're going to do 84, then you're going to hit the cosine button, and then you're going to multiply that answer by 12. So the order changes a little bit when you, depending on the calculator that you have. Okay, number 4 says a lamppost is 11 feet tall. If the angle of elevation through the top of the lamppost to the sun is 49 degrees, approximately how far is the top of the lamppost from the tip of the shadow? So we're actually going to talk about angle of elevation again today, but angle of elevation is from the ground up. So you're going to eventually be drawing these by hand without the picture, which is why you'll need to know that. Again, we'll talk about that some more today. This already gives you the picture. So you already have the lamppost, you already have the angle of elevation, and what you're looking for is how far the top of the lamppost is from the tip of the shadow. So we're looking for X, which again is marked here. I want to look at 49 and 11 and X. 49 has 11 opposite it, and X is the hypotenuse, so this is going to be sine. The sine of 49 would be opposite, which is 11, over X. Numbers in the top, so I take and divide it by the other side. X would equal 11 divided by the sine of 49. And I get X equals 14.57. It doesn't say what to round. We're going to round to the nearest tenth, which is 14.6, and this is in feet. Remember, if your calculator doesn't show sine when you hit the button that says SIN, that you're going to do this in a different order. You're going to do 11 divided by 49 sine equals, and you should get the same answer. So you definitely want to be practicing with the calculator you're going to use on next Thursday's test so that the calculator is not what causes you to lose points. Okay, chapter 7, section 7 is what's going to finish this chapter. And it's just more solving right triangles. So you're going to see some word problems in here. You're going to get some more practice with SOHCAHTOA. The first thing is what's the angle of depression, and it's probably the thing that most people mistaken on a word problem. So if somebody tells you that there's an angle of depression, it means from above the ground to the ground, or sometimes it'll be like a person sitting on the edge of the cliff or on the edge of a building, on a balcony, and the angle of depression is, and it will give you a measure. This is always from eye level down. So the mistake some people tend to make is by putting the angle in this little corner, which is wrong. You always want it to be from the level down. So if it was angle of depression of 49 degrees, then I would put 49 degrees right here in this angle here. We just saw the angle of elevation, but the angle of elevation goes from ground up. So if it says that somebody's laying on the ground and they look up at the sun and the angle of elevation is 49 degrees, then that 49 is going to go there. So if you look up at an object, the angle of your line of sight makes with the horizontal line is called the angle of elevation. Here's a person on the beach, and it's saying the angle of elevation would be from their eye level here up to whatever it is they're looking at. This would be my angle of elevation. If you look down at an object then the angle of your line of sight makes with the horizontal is called the angle of depression. So if she's looking back down here, then the angle of depression is going to be from her eye level down. Okay, if you think depressed is sad, you would be looking down, maybe hanging your head down. That's depressed. And then angle of elevation, elevation would be rising up. So you can think about it as looking up. Okay, so now we're going to do some examples. Example 1 says, draw a diagram showing a person who's 1.5 meters tall, standing 20 meters from the base of a building. Also show the person sights the top of the building with an angle of elevation of 58 degrees, and then find the height of the building. This is where you get to be fun and show off your artistic skills, and this is where I get to show off my non-existent artistic skills. So if I've got a person who's 1.5 meters tall, here's my person. They are 1.5 meters tall. And they're standing 20 feet from the base of a building. So from here to the base of a building, here's my building. They are 20 meters from that base of the building. And it says the person sights the top of the building with an angle of depression. This should be an angle of elevation, of 58 degrees. So I go from eye level to the top of that building, and this angle in here, which is angle of elevation, is 58 degrees. Find the height of the building. So the first thing you want to do is always figure out where your right triangle is, because we're doing right triangle trig. There's always going to be some sort of right triangle. So you should be able to see there's a right triangle here from the person's eye level over and up the angle of elevation. Well, if from the ground to the building is 20 meters, then so is from the eye level to the building. So I have those. And then I can solve this top right triangle to get that little segment using SOHCAHTOA. But then I've got to take into account that from here down would be 1.5, which is the height of this person. So I'm going to find the opposite side, and then I'm going to add his height, which is at 1.5 meters. So if I look at the diagram that's here, in respect to the 58, is X is my opposite side, 20 is the adjacent side, which means we're going to do, remember SOHCAHTOA, opposite and adjacent would be the TOA part, or tangent. So the tangent of 58 degrees is equal to X over 20. The 20 is in the bottom, so I'm going to multiply by 20 on both sides. Cancels from here, and I get 20 times the tangent of 58, which is 32.006. So 32.0, and this is a meters high. Again, that's just this measurement. So if I want the height of the building, I have to take that 32 meters and I have to add the 1.5 meters onto it, making the building 33.5 meters tall. Example 2 says, when the sun's angle of elevation is 38 degrees, a building casts a shadow of 45 meters. How high is the building? So again, you've got your building. And I've got it casting a shadow. So if my shadow comes back this way, it says the sun, so the sun would probably be somewhere over here, casting this shadow because it would reach back to over that building, okay? But the angle of elevation would be from the ground level up to that sun. So this angle here, actually, make sure it gets to the edge of the building, here would be 38 degrees. So angle of elevation of the sun, okay, is always going to go ground level up to the top of whatever that object is. That's 38 degrees. This shadow is 45 meters, and it wants to know how high the building is. This time we don't have to worry about anybody sighting it. You're sighting it from the ground level up. So I can just use the tangent of 38, because I have the opposite side and the adjacent side again, equals X over 45. And then multiply both sides by 45. And 45 times the tangent of 38 tells me that the height of the building is 35.15. So we're going to say this is 35.2 meters. And you don't actually need the x. It's just the height of the building, so it's 35.2. Example 3, even easier. Here's my triangle. It's already drawn for me. It says solve the right triangle, round the decimal answers to the nearest tenth. So in my triangle, which is here, I want to solve it, which means find all the missing sides, all the missing angles. I'm missing this side here. I'm missing this side here and this angle. So the angle is the easiest to find because if this is 90, 45 in this angle, A and B have to add up to 90. So if I did 90 minus 42, I get 48 degrees. You could also add 90 and 42, subtract it from 180. Either way, you get the other angles, 48 degrees. Now I just got to find my two sides. Because you have both angles now, you can actually choose which one to pick to set up as your angle. My advice is stick to the one that they originally gave you because you know that's right. And if you make a mistake here, you're going to continue to use the wrong measurement for the rest of the answers. So I'm going to use the 42 that's given to me. And then let's say I solve for x first. So x is opposite the 42, and I'm going to use the one that gave me, which is 70. That's adjacent. Opposite and adjacent is, again, tangent. So the tangent of 42 would equal the opposite side, which is x, over the adjacent, which is 70. Numbers in the bottom, so I'm just going to multiply it by both sides. 70 tangent of 42 is going to give me x, which is 63.02, and it says nearest tenth, so this is 63.0. Now the last thing I need to find is side y. So in respect to the 42, which I'm going to use again, y is now the hypotenuse of this triangle, and I'm going to use the 70 because, again, I know that's right, not rounded, and that's adjacent. So now I'm going to do cosine. The cosine of 42 would equal adjacent, which is 70, over y, the hypotenuse. Numbers in the bottom this time, so I'm going to take the top number, or sorry, numbers in the top this time. I'm going to take that number and divide it by the other side. And I get y equals 70 divided by the cosine of 42. And y is 94.19, so we're going to round that to 94.2. Now, if I had extra time, and especially with the calculator because it's a little bit easier, time saver, you can check the measurements on the sides of this triangle by using the Pythagorean theorem. I can see if 70 squared plus 63 squared equals 94.2 squared. Now, we rounded those, so they may not be exact, but they should be pretty close. So 70 squared plus 63 squared is 8,869. And then 94.2 squared is 8,873.64. So again, they're not going to be exact because we rounded both this side and this side, but it should be a little bit close, so within 4 here. Okay, last question. It says, suppose your school is building a raked stage. The stage will be 30 feet long from the front to the back with a total rise of 2 feet. A rake, or angle of elevation, of 5 degrees or less is genuinely preferred for the safety and comfort of the actors, so they're not sliding down the stage. Is the rake stage you are building within the range suggested? So here I've got a stage being built in the beginning, or on the picture, it actually shows you, here's the stage front, here's the stage back. It says that the total rise of 2 feet, so here's my vertical distance of 2 feet, and the stage is 30 feet long. That's the hypotenuse of this triangle. It wants to know if this angle here, my angle of elevation, is 5 or less. So I need to know if what I get from my angle is equal to or less than 5 degrees. This is where we're finding the angle, so we're going to use our negative ones. in respect to this angle, 2 is opposite, 30 is hypotenuse, which is sine. So the sine of an angle, which we don't know, is equal to 2 over 30. To find that angle, I'm going to do sine -1 of 2 divided by 30. Now you can reduce that if you want, but you don't need to because you're going to type it into the calculator anyways. I could do 1 over 15, it'd be the same thing. And I get that the angle, x, is 3.82 or 3.8 degrees. Now that is 5 or less than 5, which leads us to say that yes, it is within range. Or the raped stage is within range. So the important thing here is that you learn the difference between when you're trying to find the angle, when you're trying to find a side. Remember, when we're trying to find the side, we use the normal sine, cosine, tangent buttons, and when we're trying to find the angle, we use these sine -1s. All right, that wraps up not only 7.7, but also all the material that's going to be covered on your test. So for the right now, you're going to take and you're going to submit these notes. Remember, you're going to submit the warm-up and the notes all together in one file. And then you're going to use the remaining time to work on the 7.7 homework. And then on Tuesday, when I see you again, we will start reviewing for your test. Good luck. Have a great weekend, and I will see you Tuesday.